Okay, dear, you can see my screen, right?
Yes.
Okay, so what did we say about this loop? What it does? We're looping the I from 0 to 4. Am I right?
Yes, is I the new array or the new collection?
So
Or
no, I is just a variable that take a value. I is a variable, just a variable. So
okay.
are we able to use something instead of I? We can use X, we can use count. So it's up to us,
Alright.
okay? But we have
Okay.
to look this I, we use it where? So do you see here? So what is names? Do you still remember what is names?
Names was the, sorry, was it the collection?
Look
Or
at
was it the art? Um,
Mhm.
okay, so names is the array.
Yes, you're correct. Names is array. Yes. So what does it mean when I write names with an I like that? What does this mean?
So it's just the elements that are inside, right?
Yes, perfect. So if we say if I equals 0, so it means names. So it will, these names at index 0 will get me the first element in the array. Is that correct?
Yes.
Okay, perfect. And then what I will do here, so I use a method called push. So actually I can make it easy here by simplifying this step into 2 steps. So I can simply write, if this makes you more comfortable, let me put it this way. So I can say name equal names I, like that, okay? And then I can say stack names like that, and then I say push, and then I put name. So if this is more clearer to you, then you can replace that line by these two. This is a short way to actually insert the elements of the array names one by one inside the stack. If this is clearer to you, then it's fine. Both of them is okay. So which one is more clearer? This or this?
I think the previous one.
So this one is clearer.
Yes.
Okay. So do you understand now that we will get each element in every time we run this loop? We will run this loop for 5 times. Okay. Every time we go get a name from the array and push it inside the stack. Is that clear?
Yes.
Okay. Then tell me what this code does.
Mm. So over here, the not operator is used to show if it's true. Oh no, it flips it, right?
Yes, it flips it. So is empty means that if the stack is empty, then we will not run this loop. We cannot run, I mean, here we are looping through the stack to get something out of the stack. If the stack is empty, why you need to loop through it? Doesn't make sense, right? So we say not empty.
Yeah.
So this get is empty. It returns true if the stack is empty, but we are not interested if it is empty. So we say not empty. So if the stack is not empty, run this code. Do you see how it is used now?
Yes.
Clear to you?
Yes.
Okay, perfect. Then tell me what we do inside here.
So if it's not where pop is mentioned over there.
I didn't get you, Amber. Can you come again?
I'm asking which line where pop is mentioned.
Both is mentioned. What do you mean both?
No, pop, where pop is written. So the second line of code.
This one. This one? Or
Okay.
so sorry again. I still didn't get you. Where?
I was asking, what are you asking? Are you asking the second line?
Yes.
That
Yes.
what's
I
happening?
was asking. Yes, I was asking actually about these 3 lines. 1, 2,
Oh,
3. I want you to tell me what these three lines does.
okay. So we said the loop continues as long as stack names isn't empty. So so pop removes it, right? So from the stack. So the name which is at the topmost, pop removes that and then it reverses it. Um
What is this?
and then
What this add item does?
it adds the does it add the does it add what's in the array at the bottom? Does it add that to the top?
So
Or
this is we say this is a stack. This is a stack with pop and push. Okay, and then we have a collection. You remember a collection that so a collection is a collection of items, but we use with collection to add things to the collection. We use add item or remove item or has next or get next. You remember that?
oh yes, so it adds the name.
It adds the name to the collection, so it gets whatever
So,
it's the top here.
okay, so the one yes, so what was just removed, it adds that.
Yes, correct.
Okay.
Okay, so yalla. Okay, so it adds that to the collection, but it will be in the reversed order. So okay, then this is just a print statement, right?
Yes.
Okay, what do you understand from this code then?
So from what I remember, I think has next is for whatever value is in the stack. So this will loop till there are names left in the collection, right?
Yes, so by completing this loop will end once the stack is empty. So it means that we will keep taking out things from the stack until the stack totally empty. So by finishing the last element is a stack and we inserting it inside the collection will be full with items. The stack will be totally empty. So we moved everything from the stack, we put it in the collection. And then this code will loop to confirm that we got something inside the collection. So this will actually keep looping as long as there is items that is here. So in the collection, we don't really necessarily remove an item from the collection. So the collection acts, like we said before, like a 1D array. It acts like that exactly, except that we don't need to care about pointers like we're doing here. We don't need to care about the index. We just say has next. So as long as we has next, there is a next item to be printed, then we will continue getting. So first we check, okay, do we have something inside the collection? Oh, we still have. So I will print out get next. I will get this out, the first element. I will print it. I will say output. this is printing it out. And then it will automatically, the loop will automatically move here. And then if this condition see that there is something here, so it means that this is true, and then we will get that out and print it out. Is that clear so far?
Yes.
Okay, that's good. So let me try to remove that, and then I need to quickly let me do, oops, no, sorry, control collection. Okay, okay, yep. Okay, so what I wanted to share with you, actually the methods that, do you still remember that? So this is how, this is all the methods that you use with a collection. Can you still remember them? Add item here, get next, reset next, has next, is empty.
Yes, I remember these somewhat.
Perfect, excellent, yes. Okay, any question before we move on?
No.
Okay, don't be shy, okay?
Okay.
Okay, so I will pass you today a new information, although I'm rushing so that you actually said you have another class, right?
Yes.
Okay, have a look at this. So I will go directly to the point. The stack is slightly different from, the queue is slightly different from the stack, from the way it works. Here we say the stack is LIFO, L-I-F-O, last in, first out. And we always remember the stack with a stack of books that we can put on top of our disk. But the queue, imagine yourself are standing in a queue in front of a restaurant. So it means that the first person come to stand to enter the restaurant will be the first person to enter. So if you come first, you enter first. If you come last, you enter last. You come to the queue first, you enter the restaurant first. If you come last, you enter last. If you take a queue at a supermarket, the first one who come is the first one we got served out. So so we will keep adding to the queue from here, and we will keep taking out from the queue from here. The first person is the one who first come here, so he will be number one. If you want to decide who will enter the restaurant first, so it will be the first one who comes in. We say the queue is first in, first out. First in, first out means that the first person who comes, because he waited for a long time, he come first, he decided to be the first one to appear, so we will take him first. This is a prize to him, okay? So the second one who will enter is the second one who come in the queue. And then we will keep taking of the queue until we reach the last person in the queue. Then the queue will finish. So the operation that we do in the queue is two operations: dequeue and enqueue. Enqueue is something like push in the stack, but in the queues we call it enqueue. So we are pushing something to the end of our queue. When somebody comes to the queue, he does not jump to take the first position in the queue. No, he takes the last position in the queue. He stands here in the last. Did you get me?
Yes. So this is basically the opposite of stacks.
Yes, we can say it's opposite of the stack, but I want you to tie it to the real world. Imagine that you are standing in a queue in the real world. So the last person who comes, he come to the end of the queue, or he jumped to the first. Did you see any time a queue that a person come from, just we want to add something to the queue, then he jumped to the first position in the queue? Did you ever see this in real life?
Yes.
It doesn't happen, right? or it happens?
Yes. It depends if someone cuts, but I generally know.
Generally, no. Yes, we talk about general so that we can remember it. I just give you something from real life so we can remember it. So typically, anybody comes, he will look at the end of the queue and then he will stand there. So we call that in queue. In queue, we are adding something to the queue. Okay. So imagine here. So this is 9. We want to in queue the 9 to the queue, so we will add 9 to the end of the queue here. So if we want to take something out of the queue, we call dequeue. So we will take the first element of the queue and then we take it out. This is by the operation dequeue. So dequeue, it is the same like the pop in the stack. So an enqueue is same like push in the stack. Am I right? Oh, did I make it close to your mind?
Yes, I get it.
Okay, that's good. So this is in short, and this is exactly the syllabus. So the syllabus talk about this. Yeah, this is what we really need to understand about queues from the exam point of view. So they said the characteristic of the queue is first in, first out. Example of applications of the queues may be the print queues. So if you have a printer in your school and maybe 2 students decided or 3 students decided to print a document, the first person who press the print button will get his document printed first. Okay. So and also I can give an example of a physical queue, which is the one in the supermarket or the checkouts. So if you come stand first to pay and in the queue, then you will be the first person come to the queue will be the first person to pay and go out of the supermarket. Is that clear so far?
Yes.
Okay. So typically we have linear queue and circular queue. I would like you. This is. I mean, I thought that in if you are going to take the official exam, the high level exam at the end of the year, but I want you to confirm with your teacher, is the linear and circular queue coming in this exam or not? Okay. So what we explained just now is a linear queue. So what you have seen to me with me now in the graphic is a linear queue. Circular queue is slightly different. Okay.
Okay.
Okay, that's good. So I would say I would give you an example fast so that the time does not run from us. As we said, the operation that is supported in the queue, we have 3 kind of operation. I told you about in queue and dequeue. Okay, so in queue is like pushing. dequeue is like pop from the stack, and is empty. It is exactly the same like the stack. So we are checking before we do any operation on the queue. We need to check, is it empty or is it full, or if it is not empty, then we can do operation. If it is empty, there is no point of doing operation on something empty. We don't want to print nothing. It doesn't make any sense, right?
Yes.
So have a look, please, at this. What do you understand? So if we consider numbers as a queue, so numbers is a variable of type queue, and then we do the operation of in-queuing something to the queue. This is a queue. When you in-queue 5, so the queue now start to have 5. Okay.
Okay.
But I see that this is slightly not so perfect. There is a mistake in this slide again. I truly apologize because that maybe have slide from somewhere else. This is not correct here like that. I will try to correct it before I send it to you. So if I in Q5, yes, it's true that we will find 5 inside the queue like that. If I in Q4, so my queue will be 5 first and then 4 at the end. So if I in queue again 3, so I will end up having 5 4, and then the last thing that we'll have, I will be having 3 here. Okay, is it clear, Amber?
Yeah, so this is adding it.
Yes, we keep adding. Every time you call enqueue, you're adding something to the end of the queue. So again, imagine, yeah, this is our queue. So the first time we push something, or we enqueue something, it will come here 5, and then something else to be added, so it will come towards the end. So we'll add something here like that. So we add one more, which is 3, so we'll put it here. So if you decided that you want to take something out, we will not take the 3 like the stack. If we say pop in the stack, we will take from here. But in the queue, we take from here. And we call this operation dequeue. Okay, let me try to, yeah. Okay, yeah, yeah. Sorry, yeah, that is so. Okay. Again, that is possibly not perfect. So I would say if we have a queue like that, so if we want to take something out, we would take the 5 out. If we dequeue, we take the 5 out. So the first time we dequeue, we are going to get the 5 out. So when we get the 5 out, so we get x equal 5. So it means that our queue will not have this anymore. We will end up with a queue that is only having 4 and 3, because we're taking from the front and we are adding to the end. So if we call the queue again, so you remember when we call pop, so we take something out. So if we take the first item now in the queue, so we will take 4 now. So by here, if we take 4 out, we will be only having 3 in the queue. So we will take out something, we'll take 4, because this is the one in front. Am I clear so far?
Yes.
Okay, so the last time we're going to dequeue, we will take the 3 because this is the last item, and then we'll be having x equals 3, and we will have an empty queue. So we cannot try to dequeue again an empty queue. This is empty now. The queue is empty. We already take this one out. We take the 3 out. So this is totally empty. So it is always smart that we always, before we do the dequeue, we always need to check, is it empty or not? If it is not empty, we can take something out. If it is empty, there is no point. There will be an error, or it is the wrong code. Okay, fine?
Okay.
Okay, so please, this is actually the total code in pseudocode. Have a look, please, at this code and tell me what do you understand here. So this is creating a new queue, right?
Yes.
Okay, so why here, when I say the dequeue here, why it is getting in the element, why I'm getting 5 in the element? Do you have a reason for that? So I want you to tell me, I tried to enqueue 5 times. Sorry, 3 times, I apologize. Okay, so I have 5, 10, 15. Just tell me what I need to write here.
So, sorry, in queues, do you start from the bottom value or the top value?
So when you enqueue 5, where this 5 is coming, here or here?
I think in the starter.
So I put 5 here at the end or at the front?
In the front.
Okay, front like that?
Yeah.
Excellent. Yes, you're correct. Yes. So I will put the 10 where?
Then right after 5.
Excellent. Okay, what about 15?
Then right after 10.
Okay, that's good. So if I call DQ, I will take the 5 out or the 15 out.
If you DQ 15.
I will take the 15 out. You sure? If I DQ,
you take the 5 out.
Yes. So I will take the 5. So if I take the 15, this is a stack. Then you are dealing with a stack, not a queue. Okay. So this is the difference between the stack. So the stack, always, my advice to you is to always draw it like this. If you insert something inside the stack like this, you are actually forced, if you want to take something out, you're forced to take something out from here first. You cannot take the 5 first. You have to take them one by one out. Okay? So this is a stack. This is a queue. So far clear?
Yes.
Okay. I would like you to explain to me that code, please. This operation is going to do what?
It's checking if this queue is empty or no.
No, I'm talking about that. Not this one.
Oh.
One first. What does it? So I will be storing what inside the element? What number I'm going to be stored?
You're removing this, right? You're removing.
Yes, exactly. Yes, I'm removing something from the queue. But what is the number? We have our queue got 5, 10, 15. We already make one time dequeuing. So now I'm calling dequeue for the second time. The previous code, in the last line, we called the dequeue once. So if I call dequeue again, so what number I'm going to get out and store it inside element?
10.
Okay. Do you read it here or you understand it?
No, because first in, first out. So 5's gone, then 10 is the other one behind it. So then
okay,
that
so
will go out.
Perfect. Now my question to you, this condition will evaluate to true or false. So after we take 2 items of the queue, this condition will evaluate to true or false.
It's gonna be false because the queue isn't empty.
And what is remaining inside the queue at the moment?
It has 10, right?
We do the DQ 2 times, so we removed 2 items. So which one is remaining now? We removed 2 items.
Yes, 15 is remaining.
15 is remaining?
Yeah.
Okay, excellent. Yes, that is excellent. Yes. So yeah, that is totally correct. That is totally correct. So I would say I will stop here. Or do you want to continue? Now we are almost an hour. Would you like to continue or you would like to go for your other class?
I have another class, so I'll have to go for that.
Okay, so please, if you want to take a class tomorrow, you have to tell me the timing. I have an afternoon free on my time zone. So I would say below 5 p.m. also, I think it's still possible to give you a class. But confirm that to me, please. Okay?
Okay.
Are you able to confirm it by today?
Yes, I'll confirm it by today.
Okay. Thanks a lot. Take care. Bye-bye.
Thank you. Bye.